Okay, so hello everyone. My name is Ludovic dos Santos. I'm currently ending my PhD at UPMC under the supervision of Benjamin Piwowarski and Patrick Gallinari, and I'm going to preview our work, namely Gaussian embedding for collaborating filtering. So in the context of recommendation, we deal with large repositories of items, and we have access to past ratings of users and items. The goal is to propose relevant items to users, and nowadays collaborative filtering methods achieve really good results, and especially those using the representation learning framework that aims at learning a vector representation for each instance. The problem is that there is several sources of uncertainty inherent to those datasets, such as lack of information, for example, a new user which have very few rated items, or basically contradiction between the users and items ratings. And unfortunately, matrix factorization based techniques which are commonly used do not consider the uncertainty of the learned representations. So we came with the idea of handling this uncertainty, and we use the relatively recent framework, the Gaussian embedding learning framework, which instead of learning deterministic embeddings, learn Gaussian variable for each instance, characterized by its mean and its covariance matrix, which are the parameters we want to learn. Our hypothesis is that this variance will capture the uncertainty and the conflicting information inherent to the dataset. So here's a basic example of what advantage using this new framework brings in comparison to the deterministic one. Here's XU is the representation of a users, and we have three items, I, J, and K, which have the same mean in the latent space. So basically, using a deterministic framework, those three items will have roughly the same score, which is a function of the dot product of the mean. And using a Gaussian learning framework, we'll distinguish those items, since the resulting distribution of the score, which is the scalar product between the Gaussian variables, will have different variances and also different modes. So we propose a model that, instead of modeling the posterior probability by a function of the scalar product of the deterministic representation, will use the Gaussian learned embedding and directly estimate this posterior probability. So to summarize, we have proposed a distributed representation-based model that learn Gaussian embedding for each user and item. And our experiments show that the use of uncertainty have improved the results, and we have found some interesting properties about those learned representations, such as giving more liberty to the model by increasing the dimension of the representation space, results in less use of the variance by the model, or increasing the training size results in lowering the variance of the representation. So thank you, and don't hesitate to come to my poster.
So actually, if someone has a question or a comment, we do have time for one. Otherwise, we're going to go to the next. Thanks again.